3.5 Lesson 2, Displacement, Velocity, and Acceleration. Our objectives for today's lesson are 1. Given f prime of x, given the derivative of a function f, you will be able to find the function f, called an antiderivative of f prime. You'll be able to, objective 2, you'll be able to solve word problems involving antiderivatives. So yesterday we learned that velocity is the first derivative of the displacement or the position function. Acceleration is the second derivative of the displacement function or the first derivative of the velocity function. Today we're going to consider a problem in which you're given the velocity function. So you have to think backwards to find the position or the displacement function, and that process is called an antiderivative, and that process is called antidifferentiation. We use a particular notation to indicate this type of work. It's called an indefinite integral, and we will see what we mean by a constant of integration. Now we will take a look at objective 1. Given the derivative, you'll be able to find the function from which you obtain the derivative. And that function is called an antiderivative of f prime. Before we look at objective 1, let's set it up as follows. So here we have a function f for number 1, and for number 2 we have a function g. So this is not objective 1, but this is leading up to objective 1. So we know how to find the derivative of the function f. We will use the power rule. 3x squared would be the derivative of x cubed. And then we will use the differentiation rule for a sum of two functions. So you find the sum of the derivatives, and the derivative of the constant 2 is 0. And for the second problem, to find g prime of x, again, what you have here is a sum of two differentiable functions. The first function is the power function, and the second function is the constant function. So the derivative of the first function is given by the power rule, and the derivative of the constant 5 would be 0, and you have the sum of those two derivatives. So you have for number 1, f prime of x is 3x squared. And for number 2, you have g prime of x is 3x squared. You will notice one thing right away. The original functions were different. F of x was x cubed plus 2. G of x was x cubed plus 5. But they have the same derivatives. And why is that? That's because the only difference between the original functions was the constant that was added to x cubed. For number 1, 2 was added to x cubed, and for number 2, 5 was added to x cubed. But when we found the derivatives, the derivative of any constant is 0, so that's why we got the same derivatives. So now when you think about antidifferentiation, you have to remember what we just discussed. Now we're ready to take a look at objective 1. Given the derivative, you'll be able to find the function from which the derivative was obtained. And that original function is called an antiderivative of f prime. So we're going to look at 1b and 2b, find the indefinite integrals. Indefinite integral means antiderivative. So you're going to be looking for antiderivatives here. So f prime of x is 3x squared, and you're integrating with respect to x. For indefinite integral, there are no limits of integration. You're just looking for an antiderivative. That's what indefinite integral means. There are no limits of integration. It's different from a definite integral. Here you're just looking for an antiderivative. So how do you look for an antiderivative? You have to do the reverse of what you did in differentiation. So in the power rule, for the power rule, how did you find the derivative of x cubed? Here's what you did. For the power rule, you took the exponent, brought it to the front, and subtracted 1 from the exponent. And that's how you found the derivative of f of x is equal to x cubed plus 2. You took the exponent 3, brought it to the front, and subtracted 1 from 3 to get 2 for the new exponent. So if you want to reverse that, you have to undo those steps in the reverse order. So you're going to begin by undoing the subtraction of 1 from the exponent. So to undo subtraction of 1, you're going to add 1 to the exponent of 2 here. So when we do that, we're going to get 3x cubed. And then you have to undo what was done first, which was you multiplied by the original exponent of 3. So now you're going to divide by the new exponent of 3. And then you need to have something called a constant of integration. The reason for that is because in the original function, you could have had some constant that perhaps you're not aware of in this process of finding an indefinite integral. So now you're going to have your final answer will be x cubed plus c plus some constant of integration, and this would be your function f of x. And what could c be? Well, it could be 2, it could be 5, or it could be some other constant. You won't be able to tell unless you have additional information called an initial condition. So now we take a look at 2b. It's the same problem that I did for 1b, so you'll get the same result. You're going to do the same process that we talked about. To undo the differentiation, you will add 1 to the exponent, so that will give you x cubed, and then you will divide by the new exponent. And then you have the constant of integration plus c. And this will give you g of x will be x cubed plus c. And the reason why we need that constant of integration is because, as you can tell from numbers 1 and 2, number 1, I actually had x cubed plus 2. Number 2, I actually had x cubed plus 5. So when I'm finding the antiderivative, I'm getting the x cubed part, but I'm not really sure if I should add a constant after that or not, or what constant I should add. And unless I have more information, I can't really tell, so I just leave it as plus c. What additional information could you have for a problem like 1b or 2b? So at the top of the screen, I've rewritten a summary of what we just did on the previous screen. And in 1c, we're going to have initial conditions. What's an initial condition? An initial condition is some information about the original function f, or for 2c, some information about the original function g. So for example, if you look at the original function f for number 1, and you evaluate the function at x is equal to 0, then you're going to have 0 cubed plus 2. So this would be an initial condition. When x is 0, y is 2. Or for number 2, if I evaluate the function g at x is equal to 1, I'm going to have 1 cubed plus 5, which will give me 6. That would also be an initial condition. With these initial conditions, I can take the work that I did in 1b and 2b and find the particular value of the constant of integration that would help me to find that the original function f had the constant 2 and the original function g had the constant 5, even though when I did 1b and 2b, I got that f of x and g of x were both x cubed plus some constant of integration. We call 1b and 2b the general solutions of a differential equation, and 1c and 2c are called particular solutions of the differential equation, but we'll use that vocabulary in the future. So I take my result from 1b, I get f of x is equal to x cubed plus c. I take my result from 2b. I had g of x is equal to x cubed plus c. And to find what c should be, I will use the initial conditions for each problem. So basically, for the function f, for 1c, when x is 0, y is 2. And of course, f of x is y. So when x is 0, I have 0 cubed plus c, y would be 2. And that tells me when I solve for c, 0 cubed is 0, so I get that c should be 2. And I get f of x should be x cubed plus 2. And if you look at 2c, now that with my initial condition, I can find what c should be for the original function g. For the original function g, when x is 1, y is 6. And of course, g of x is y. So I replace that with 6, and I replace x with 1. So I have 1 cubed plus c is equal to 6. 1 cubed is 1. So when I solve for c, I subtract 1 from both sides of the equation, and I get c is 5, giving me g of x is equal to x cubed plus 5, using the initial condition that was given. So we just took a look at objective 1. Given f prime of x, you'll be able to find f of x called an antiderivative of f prime. Let's look at objective 2. You'll be able to solve word problems involving antiderivatives. And we're going to take a look at our problem from yesterday, number 5, where we had a given displacement or position function, and yesterday we learned that the derivative of the displacement function gave us the velocity function, and the derivative of the velocity function gave us the acceleration function. Today we're going to think about it like this. Suppose you're given the velocity function and some initial condition about the position function. We're going to find what the position function was by finding an antiderivative of the velocity function, or indefinite integral of the velocity function, which will have a constant of integration, but we will be able to use the initial condition to figure out what the constant of integration should be equal to. So this was the problem from yesterday. An object moves as in problem 3 with displacement given by this function, where x is measured in feet and time is measured in seconds. Yesterday we were able to find the equations for velocity and acceleration. Velocity is the first derivative of the displacement function, so we had negative 3t squared plus 26t minus 35. That was the velocity function. And you can find acceleration by taking the derivative of velocity. But today, suppose we don't know what the position function is, but we just have the velocity function. But you do know an initial condition about the position or the displacement function. So let's say you know that at time t equals 0, the position of the object is at x is equal to 27. The position of the object on the x-axis is at x is equal to 27. So in other words, you have the ordered pair time is 0 and x is 27. So this is called an initial condition. So suppose you have this initial condition about the position function, and you have the velocity function, but you don't know what the position function was. And today you want to find out, what is the position function? We want to find out. How can we find out? Velocity is the derivative of the position function, so the position function is the antiderivative of the velocity function, or the indefinite integral. So the position function can be found by finding an antiderivative of the velocity function, also called an indefinite integral. Don't forget to write the dt here. And remember, for an antiderivative, there are no limits of integration for an indefinite integral. So now we're just going to go ahead and do this. So the velocity function is negative 3t squared plus 26t minus 35 dt. And now you're going to integrate term by term. Just like we saw with the previous example, you're going to add 1 to the exponent here. And when you do that, you get t cubed, and you'll divide by the new exponent of 3. Here, the exponent is 1, so when you add 1 to that, you get 2. So you have 26t squared, and divide that by 2, the new exponent. Here you have minus 35, so you're going to write minus 35t. If you differentiate minus 35t, you will get minus 35. And then, just like we saw with our previous examples for the first objective, you need to write a constant of integration. This is your, what we call the general solution of the differential equation. It's your position function, almost, except that you have to figure out what the constant c should be. And to figure that out, you're going to use the initial condition that was given. At time is equal to 0, the position of the object is at x is equal to 27. So using that, I can solve for c. I'm going to substitute 27 for x. So I write 27 for x. And I'm going to substitute 0 for t. So I have, first of all, maybe I want to clean up my answer for x of t a little bit. X of t is equal to 3 divided by 3 is 1. So I have negative t cubed. 26 divided by 2 is 13. So I have plus 13t squared minus 35t plus c. So I cleaned it up a little bit. And now I will substitute 27 for x and 0 for t. So when I do that, I will have minus 0 cubed plus 13 0 squared minus 35 times t. T is 0 and x is 27, right? So I have plus c. So you can see that this is 0, this term will be 0, and this term will be 0. So I have 27 is equal to c. So now I know that c should be 27, which means my displacement function would be x of t is equal to negative t cubed plus 13t squared minus 35t plus 27. And so in this problem, I was given the velocity function and an initial condition for the position function, and I was able to find an antiderivative of the velocity function with a constant of integration, but then I used the initial condition for the position function to find what the value of that constant should be. This is called antidifferentiation, or finding an indefinite integral. And of course, compare what I found for x of t to what x of t was, and you'll see that I found it, right? X of t is equal to negative t cubed plus 13t squared minus 35t plus 27. So we just completed objective 2. You'll be able to solve word problems involving antiderivatives.